The switch statement is basically branching out to different places based on an expression. That's what it means. So based on the value of an expression, the system will switch to one or the other statements. So you write it this way: switch and then an expression. And if the expression evaluates to be equal to constant 2, for example, then it will do this statement and all the other cases below it. So it doesn't stop there. It will execute all the statements below it, including the default statements. Usually default means if the expression doesn't match any of these constants, any of them, then do the default. That's what the default is written for. But if it matches any of the constants, then it'll start at that constant and do everything below it. So wherever it starts, it does all the other cases below it. That's how the switch works. If you don't want the other cases, then you have to tell the system you don't want the other cases. There are ways to do that. Okay, so let's go to yeah, already explained that. So let's go to the important things we need to remember is the index of the switch, the expression that you write, has to evaluate to be an integer or character. No other values allowed. So if your value is going to be something else, like a float number, the switch will fail. You'll get error message. Okay, and the other is default is not required. It's only optional. You can have many statements in each case, and you don't need brackets around them if you have multiple statements. Okay, so let's see a simple example. Write a program that will determine whether the number received from the user is divisible by 5 or not, or whether it's a multiple of 5 or not. If it's a multiple of 5, then it will be divisible by 5. So we can write the program. Of course, we can write it with the if statement. So like I said before, the switch statement is an alternate to if statement. Sometimes it's convenient, more convenient than the if statement. That's why we like to use it. So in this case, it's we want to see if the number entered by the user is a multiple of 5 or not. So ask the user for the number and read it into M. And then M modulus 5 seems to be a good expression to evaluate, because if M is a multiple of 5, then M modulus 5 will be 0. If it is not multiple of 5, then it'll be 1, 2, 3, or 4. There are 4 possible numbers if it is not divisible. The remainder of dividing by 5 will be less than 5. That's all we know. So it would be 0, 1, 2, 3, or 4. So if you're writing it with switch, then you have to cover all the possibilities. K0 means if the modulus 5 is equal to 0, then I'm saying C out, number is a multiple of 5. Write the conclusion. If it is not 0, then it can be 1 or 2 or 3 or 4. I'm leaving these cases blank because I know that if it comes to case 1 or 2 or 3, it will do everything below that. So therefore, if I write this as my conclusion in the case 4, it will be printed in all these cases. In all these cases, this is the outcome. So that's why I don't have to write anything in the case 1, 2, 3. Because I know that it will execute all of them. We don't want to write the same conclusion over and over. So that's why I wrote it only with the case 4. So this will work, and it will produce the answer. But it's not perfectly right. There is something not quite right here. Anybody recognize that?
Do you need all of those cases, or can you just put like case 0 and case 1?
Okay, if you just write case 0 and case 1, that's going to be wrong, because let's say the number is 7, M is 7, then M modulus 5 is 2. And if you don't have this case 2 and case 3, case 4, then it's not going to write any conclusion for you. when the remainder is 2. Okay.
Okay, I understand. Yeah. Okay, got it.
Okay. So the remainder can be 1, 2, 3, or 4. So you have to cover all the possible cases, all the possible remainders, and take care of all of them. And if you don't, then you won't get any conclusion. So that, but there is still a small problem here. Can anybody recognize that? It's not perfectly right. It'll run, but it's not going to produce the result the way we like. Anybody see that? Okay, let me explain. Let's say M modulus 5 is 0, like M is 15. If M is 15, then M modulus 5 is 0, and it'll come to the case 0, and it'll write this conclusion, and it'll continue on to do all the other cases, and it'll end up writing this conclusion. Isn't that right? Which is not right, because we are writing 2 opposite conclusions. We should only write 1 conclusion. Everybody see the problem? If it goes to any case, it'll go and do everything below that case. So if it goes to case 0, it will do this, and it'll end up doing this also, which is wrong. We have 2 opposite conclusions. So we need to do something. We don't want both of those conclusions. That's why the switch statement allows you to use a break statement. A break statement would break out of any structure. If you put break statement anywhere in any structure, there are other structures we'll be learning later on. You can break out of any structure by using this. But as a rule for the programmers, even though break statement is open to be used anywhere, as a rule to avoid sloppy programming, hard to read programming, we have a rule that you don't use break anywhere else. You only use it with the switch statement. No other structures should have a break statement in it. It is completely prohibited because it's bad programming to use that in any other structure. Okay, so remember that. You cannot use break statement in the other structures. You will be penalized severely for that. Very often students use them in loop structures. Loop structures, sometimes difficult to figure out how to make the loop stop at the right point. And so they use the break as an easy way out. But using break is bad practice, because it's not only creating chances of getting wrong program, but also hard to read for anybody else reading it. You're jumping around in a program from one place to the other. That's not good practice. So you should, simply remember the break statement you're allowed to use only in the switch statement, nowhere else. Okay, so how do we use the break statement? Right after the first case 0, I need to put break. So here is how it is. I have to have this break statement right next to the cout statement. That way, after writing this, it will leave. This will make it leave the switch entirely and go to the statement after the switch. So it will not end up doing any of these. That's what we need here. Okay, so let me ask another question. Is there any other way to write, instead of writing case 1, 2, 3, 4 for the situation of the number being not divisible by 5? In other words, the number is multiple of 5. In the case 0, it is multiple of 5. In any other case, it's not multiple of 5. So is there a different way to write it, anybody?
Could you use the default?
Exactly. Very good. Exactly. That's exactly what I had in mind. So instead of all these cases, you could have put default. So you could have written this program with this right there. That'll be still correct. So if it doesn't match 0, then it'll be not multiple of 5. And it's perfectly right program to write it this way. All right, so let's go to the next example. Next example is about writing the letter grades A, B, C, D, E for a class. So the program you're going to write will take the grade of the student and convert it to letter grade. So if the grade is under 60, it's fail. 60 to 70 is D, and 70 to 80 is C. We wrote this program using nested if structure. So like I said before, switch is an alternate to nested if structure. So if I want to write this program using nested if, how do we do it? That's what we want to see. Now, switch statement doesn't handle intervals, inequalities. None of that can be handled here. No inequalities, no intervals. Here, you can only have an expression that translates to a number, and that number will be what your rest of the switch will be based on. What number is the value of the expression. So I have to translate all those intervals under 60 and 60 to 70, 70 to 80, all these intervals into integers. So I have to come up with an expression that will convert those intervals into integers. And that's a tricky part sometimes. And there are sometimes more than one expression that will work out. I'm going to show you one expression that will work out in this case. And then I'll also show you that there are other ways. There are more than one expression that can work. So it's not unique. The expression you can use is not unique. So the expression I'm going to use is take the grade of the student and subtract 50 and divide by 10. This is just one expression that will work. Grade minus 50 and divided by 10. If I do that, I'll explain first on the board. When the grade is over 60, like 63, let's say. 63 minus 50 is 13, and divided by 10 will be 1.3. And can you see that if it is any number above 60, the integer part will be 1. So any number above 60 but below 70. So like even 69. 69 will be minus 50 will be 19 over 10 is 1.9, and integer part is 1. So for any number in the range 60 to 70, you will get a 1 from this. And when you go above 70, like 73, you can see that 73 minus 60 is 23. Divide by 10 and take integer part, it will be 2. So any number above 70 under 80 will produce 2. Any number above 80 under 90 will be 3. Anything above 90 will be 4, like 94. If you take 94 minus 60, it will be 44. Divide by 10, 60. Divide by 10, it'll be 4. 94 minus 60 is 34. 50. Sorry, I'm using wrong number there. 50 is 44. Divide by 10 is 4.4. Integer part is 4. So above 90 will be producing 4. But then you had to worry about the 100. There is 100 is a possibility, right? So when the grade is 100, minus 50 over 10 will be 5. So grade A can happen when the number is 5 or 4. There are 2 possibilities. So if we allow that, we can see that the expression will become either 4 or 5 when the grade is A. It will become 3 when the grade is B. It will become 2 when the grade is C. So that's how you translate the intervals into integers. So this expression works. So I'm going to show you the program. Here's the program. You use, you get the grade from the user, and then grade minus 50 over 10 is your expression. You call it index. There's index, the expression that you use in the switch is often called index. So I'm using that as the name. Index equal to this. Switch based on index, the value of index. Case 5 and 4, the grade is A, and break, right? 5 and 4 other cases for A. If the value is 3, then we know it's B, so see out B and break. If it is 2, then see out C and break. If it is 1, see out D and break. Now, all other numbers, when the number is under 60, it can be under 40, under 30, you know, we don't know where it is. So we don't have to worry about it. If it is under 60, it can be 0, it can be a negative number. So we'll put it all under the default. If it is anything other than the above numbers, we know it's F, right? It must be under 60. We covered all the other possibilities. So if it is not falling under any of those cases, it must be under 60. So see out grade is F. And it works out. Now, so is this the only way, grade minus 50 over 10? Is that the only expression that works? If that's the only expression that works, then it's going to be hard for somebody to figure out. But fortunately, you can make the program work with a variety of different expressions. Sometimes, you know, 1 or 2, sometimes more than 2 ways to do it. So I'm going to show you another expression that can work. The program can be written with that, and I'll explain how that works, and then you will understand better. So instead of this, if I use index equal to just simply grade divided by 10. If I simply divide by 10, will that work? Okay, let's think about it. If the grade is over 90, let's start with the 90. If it is over 90, then 93, for example, divided by 10 will be 9.3. But if I declare index as int, then I'm picking up integer part. Can you see that? It'll be a 9, no matter what the number is. If it is over 90, then I'll get 9. Is there another number possibly I can get? Anybody? If it is over 90, there are 2 possible numbers. And I'm trying to see if anybody recognizes the other number.
Could you get 10?
10 is right, very good. Because the grade can be 100. If the grade is 100, grade over 10 will be 10. Integer part of it will be 10. So therefore 9 and 10 are 2 possible values for A. If the grade is going to be B, like the grade will be between 80 and 90. When the grade is between 80 and 90, what is the number for this? Nobody can see it? The grade is between 80 and 90, then what will be the value of index?
8.
4.
No,
Right,
8 or 9?
not 9. You'll get 9 only if it is above 90, right?
Okay.
Somebody said 4. How do you get 4? When the grade is over 90, like 92, then when you divide by 10, it'll be 9.2. Integer part of it is 9. And that's the same story with any number above 90, except for 100. If it is 100, 100 over 10 is 10. So therefore, 9 and 10 are the only possible numbers when the grade is over 90. When the grade is over 80, under 90, it has to be 8. You see that? If the grade is 81, 80 or 81, 82, all the way to 89. For any of those numbers, this expression index will be 8. Everybody see that?
Yes.
All right. So case 10 and case 9, see out A. Agree with that? Then comes case 8. Case 8, I have to put a break here, break. And then case 8, see out B, break. Case 7 will be what?
7.
Yeah, what's the grade?
Oh, see out C.
C, right. See out C. Break. Case 6 will be the D, right? 60 and above, you'll get 6. So see out D. And how do we handle the rest?
To use default.
See out F.
Default, right. In any other case, we can bring it down to default. Default, see out F. And that, as you can see, takes care of it. 9, 8, 7, 6 are the numbers. The numbers don't have to be sequential, any numbers, whatever that works out. So just dividing grade by 10 works out in this case. So there can be more than one expression that will work. Okay, so let's move on to another.
Is there a reason why the first case never has anything in it, and you always start in like case 9 or case 4 and the other one?
I didn't get that question. You're referring to my second version, right? This version with the index equal to grade over 10?
Yes.
Yes. And the index will be 10 or 9 in the case the grade is A. Grade is above 90, we'll get 10 or 9. Is that where the question is?
Yes, so you didn't write anything for case 10 because there's a possibility.
Oh, that's because if it goes to case 10, if it goes to 10, the grade is A, right? So I don't need to see out A here. I don't need that because if it goes to 10, it's going to go to 9 also. Remember, if it goes anywhere, it'll go below to all the other cases. So it will go to 9 also. I don't have a break statement at the 10. So if it goes to 10, it'll go down to 9 as well. And so it's going to end up writing the C out, end up writing the grade A, whether it goes to 10 or 9.
Got it.
All right. That's why I didn't, if I write another C out A here, then I'll be repeating the A on the screen twice. I don't want to repeat that grade A twice on the screen. That's why I didn't write anything there. This way the grade A will be written only once. And if it goes to 8, it will write the B, and then we have a break statement, so it will break out of the structure. If it goes to 7, it will write C and break out. If it goes to 6, it will write D, and I do need a break there. And then the default will be F. I don't need a break after default. It will break out when it hits this bracket. Any other question on that? Okay. So here is the, here's the second version with the grade over 10. I just wrote it on the screen. I wrote on the board, but you have it here. Okay, so let's do another example with the characters. This problem says, write a program that'll get a character from the user and determine whether or not it's a punctuation character and writes the conclusion. Okay, so I asked the user to enter the character and read it into the variable val. And then I'm using val itself as my index. And if val matches period, I have to put the period in quotes. Any character data should be used in quotes. If it matches period or matches comma or matches colon or any one of these, then our conclusion is it is punctuation character and break. If it doesn't match any of them, it'll come to the default case and you say no punctuation, not a punctuation character. And that's it. Now, I didn't write all the punctuation characters here. I simplified it, but there are many more punctuation characters you had to put in the list. But as you can see, I only need to write one conclusion for all those cases. So that will be, that's how you handle that. Let's do an exercise, a warm-up exercise. It says a departmental store is about to have a sale. Prices are to be reduced by a percentage determined by the following rule. So if the current price is in the range 0 to 30, then reduce by 10%. If it is 30 to 60, reduce by 12%, and so on. So write a program that will get the current price from the user, and then it'll print the new price. Okay, so basically the expression that you can use, you had to figure out that if you want to use switch statement. Now, obviously you can use nested if statement, right, easily. But we want to practice with the switch statement. So if you come up with an expression, then give it to me and I will tell you whether that can work or not. And then you can go ahead and write the program. So when you have the expression, you can write it on the chat and I'll check it out. Go ahead. Okay, Christine, your expression can work. So go ahead and try to write the entire program with that. Okay, let me see. No one else has an expression? if anybody has a expression you want to try, then first show me that, by putting it on the chat before writing the program, so that I can tell you whether it's going to work or not. All right. No one else has anything? Okay, one student gave me an expression of dividing the price by 10. That can work, and there's nothing else that is easy enough that I can see. Price minus 20 over 10 can be worked out, but it looks harder than just dividing by 10. So therefore, I'm going to use the expression of dividing by 10 and work it out. So main, and then float price. And then you need to get the price, current price from the user. So see out, enter price. See in price. And then my index, I have to declare index up here somewhere. And then my index is going to be, I declared it as integer. So therefore, if I divide price by 10, then I'm taking integer part into index. So index will have the integer part of dividing by 10. Now we have to figure out all the values index can have. So switch. So I need to switch now based on index case. If the number is in the range 0 to 30, then it'll be, as you can see, if it is like 20 something, then it'll be 2. But it can be also less than 20 or less than 10. So it can be 0, 1, or I'm sorry, 0, 1, 2, 3. 0, 1, 2. Those are the possibilities. It's less than 30. So if it is like 25, then you're going to get 2. When you divide by 10 and take integer part, you'll get 2. If it is like 15, then you're going to get 1. But if it is 9 or 8, you're going to get 0, integer part, when you divide by 10 and get integer part. So the possible values are, so remember, you have to take care of all possible values. Otherwise, program will fail. It will not give you the right results. So here, the possible values for the range 0 to 30 are 0, 1, and 2. So I have to put all those cases. Case 0, case 1, case 2. All 3 cases, case 2, in all 3 cases, my percentage is 10. So I'm going to use a variable called percentage. I'll declare that here, percent, and I just need to put percentage as 10%, 0.1, and break right there. And then if it is in the range 30 to 60, then when you divide by 10 and take integer part, it'll be 3, 4, or 5, 3, 4, 5. So case 3, case 4, case 5. In all these cases, it is in the range 30 to 60. So percent equal to 0.12. And then if it is in the range 60 to 90, it'll be 6, 7, 8, 3 numbers. 6, case 7, case 8. In all those cases, it's 15%. So percent is 0.15. And if it is 90 or above, now when it's 90 or above, it could be 95 or 105 or even 205. See, there's a huge range when you say about 90. This is about price. In the last problem, we had grade. We knew that the grade is not going to go over 100. So we were limited by 100. But here it's unlimited. So you have to pay attention and work out your program correctly. So what should I do? How do I handle that?
You should use the default.
Default. So all other cases I'm going to put under default. If it is not one of these, then it's clearly over 90 and it can be anything, anywhere about 90. So I cannot cover all the possibilities. Default is the best way. So default percent equal to 0.2. I forgot to put the break in the other places. I need break everywhere. I don't need break after default. So close. And then now after this, this is closing the switch. I just closed the switch here. And after the switch is closed, I can now say price equal to, I'm going to reduce the price by the percentage. The percent has the correct percentage. So price equal to price minus price times percent. Whatever the percent is that we have calculated. And that will be the new price. So see out price. And that finishes the program. So the switch statement takes care of figuring out the correct percentage. And in this case, we had to we have 3 numbers for each interval. That will be okay. 3 numbers for each interval. But if you're getting 10 different numbers for each interval, that's too long. That's too much. So you had to figure out a different expression in that case. So here it is possible that another expression will bring down the numbers for each interval to 1 number instead of 3 numbers. So it's a matter of sitting down and figuring out, doing the math. You know, it's a little bit of math you had to work out. But if you write the program this way, that'll be acceptable. 3 numbers for each interval is acceptable. Okay, so that finishes section 3.5. So you'll have to do the homework on 3.5, and we're going to do 4.1 as much as possible. So let me move on to 4.1. Let me clear the board. So 4.1 is about loops. That's the wrong place to go to the beginning. Loops. Basically, a loop means asking the system to repeat one statement or a collection of statements over and over. So we call it loop because it's going back and forth, you know, within certain statements, repeating certain statements over and over. So it's called loop. We're going to work with 3 different ways of writing loop. The loop structure is the same thing. It's just bunch of statements being repeated. But we will do it with 3 different structures. One is called while loop. The while loop will say, while this is true, keep repeating. That's what it's going to say. While something is true, keep repeating. Do while is while kind of similar to while, so I'm not going to be discussing much of that. But for loop is a different way of writing the same loop. It's more convenient in certain situations. So therefore, we will be discussing for loop also. So let's look at while loop and see exactly how while loop is written. You write while, and then you write an expression. And this means while this expression remains true, repeat this statement. So if you have one statement next to it without any brackets, that means you're only saying repeat this one statement. So while that expression remains true, it'll do this over and over. Now you have to make sure that the expression will become false at some point. Otherwise, you have an infinite loop. What we call infinite loop will get your computer stuck with that statement forever, and it'll never get out. And the only way to get out will be to use Control-Alt-Delete in your Windows computer, or turning off the computer altogether. That's the only way to get out. So you don't want to get into an infinite loop. So when you write the program, you have to make sure the loop will end when the task is finished. Usually it's fairly straightforward. Now, in the second version of while, you have an expression. While this expression is true, all these statements will be executed. If you want many statements to be executed, you have to have curly brackets around them. If you don't have curly bracket, only one statement is in the loop, just like the if statement. Curly bracket makes it all inside, and if the brackets are missing, only one statement is inside. So only one statement will be repeated. All right, so let's understand this using a simple example, simple task. Suppose that I want to write the numbers 1, 2, 3, all the way to 100 on the screen. I want a program that will that'll make the system write numbers 1 through 100 on the screen. Okay, so we don't have a nice way of writing that program. All we can do from the current statements that we have is to say cout1 ENDL, cout2 ENDL, cout3 ENDL. That'll be 100 statements you had to write. That's not right. We have to write too many things. Now, what if it is not 100, it's 1,000? You want to write all the numbers from 1 to 1,000, then it'll be 1,000 lines. That's not right. There must be a better way. That's why they came up with this loop idea. So instead of writing those, I can now say this. Store the value 1 in the variable num or n. I'm going to store 1 in n, and then I say cout n ENDL. That'll write 1, and then increment n by 1. And then if I can make it go back and execute this now, then it'll be writing 2, and then make it execute this, it'll be incrementing to 3, and then it'll write 3. So if I can make this statement, these two statements repeat over and over, then I can get those numbers written, 1 through 100. So I need to tell the system, repeat these. Repeat these while what is true. Anybody? I need to say repeat these, right? I have already started the n at 1. I have stored 1 in n. So now if the cout is executed, it'll write 1. Then n will become 2, and then it'll write 2. Then n becomes 3. It'll write 3 and keep going. So I need to put a while statement before these two lines and say, while what is true, these two should be repeated.
Is it that n is less than 100?
N is less than or equal to 100, because when it is 100,
Right.
you still want to write it, right?
Yeah.
So
Yeah.
that's or equal to, that's very good. That's right. So I need to say, while n is less than or equal to 100, repeat these two. So while n is less than or equal to 100, I need to repeat the two statements. So I need brackets, C out, n, ENDL, and then n equal to n plus 1. If I repeat these two, then I will get the numbers written. So you can see the need for the while loop. This simple structure will end up writing all numbers 1 through 100 on the screen. Okay, so remember when the while statement is executed, the first thing it does is evaluating this expression. So when you write the while loop, you have to make sure that the expression will be true at the beginning. If they very commonly students write the program with this expression evaluating to be false at the beginning. If it is false, what happens? The loop will never stop. Nothing will be done. So it has to be true at the beginning. Only then it will do all these statements. So when it is true, it will do these statements. And when it hits this bracket, it'll go back to the top and it'll reevaluate the expression. And if it is still true, it'll do these expressions, statements. And then when it hits the bracket, it'll go back to the top, evaluate the expression again. So it'll evaluate the expression over and over. And when it becomes false, it'll terminate. So one of these statements you're writing here must change your expression to a false at some point. And if you look at the version of the program we have here, the D is, now n less than 100 is true initially. The n was set to 1. Int n equal to 1. So n was 1, so this condition is true. That's why it writes the 1 on the screen, and then go to the next line, and n changes. N is this memory cell. It was 1 before, now it changes to 2, and n changes to 2. With that new n, it goes back to the top. Still, this is true. So it'll write the 2, and then it will become 3. It will become 3, and it'll write 3, and it'll become 4. And as you can see, it's working. You have to check always the last step also. You should check the last step and make sure it's going to do exactly what you want. So n becomes 100 at some point, right? When n becomes 100, what happens? This condition is true. If I had it n less than 100 without the equal sign, then when n is equal to 100, the condition is false. But I included the equal sign because when n is equal to 100, I wanted the condition to be true. So it is true now. So it will see out the 100. So the 100 will be written. Then the n becomes 101. And now it goes to the top, n is 101, so this condition is false, and it won't write it. Loop ends at that point. So 101 is not written, but n does become 101. If I change this inequality to less than, then the 100 will not be written. If that's what you want. If you want 1 through 99, then that'll be correct program. But we want it 1 through 100. That's why the condition was less than or equal. So the program will write all 100 numbers and then it will stop. You have to make sure the loop will stop when the task is finished. That's the tricky part. So, some students, there are other ways. I mean, using break statement, if you use break statement, you can write this in a way, and I can write one, but I don't want you to write that. Remember, I explained to you, using break statement in a loop is horrible practice, and it's prohibited in any programming class. But here is what students. This program I'm going to write is correct, but it's bad practice. While yeah, you said int n equal to 1, and then while true. You are writing the logical value true inside the parentheses. That means what? You're saying my condition is true forever. and you're not changing your condition. It's going to stay at true. And then C out. Believe it or not, people write the program this way. This is a horrible way of writing, but it is written this way. C out. I'm right now explaining this only to tell you never to do this. C out n, ENDL, and then n equal to n plus 1. And then if this is the easy way, they are, you know, they don't want to think too much about it, so they take the easy way out. If n greater than 100, break. Is this going to work? It'll work. You're breaking out of the loop prematurely without turning the condition false. So this is considered to be bad programming practice. And so I don't want anybody to write program like this. Okay, so the right way to write it is to use the condition in the loop that will become false when the task is finished. And if you do that, then it'll be perfectly right. All right, so let's go on to the right program. The program I just went over on the board. This is the program. So when the numbers will be 1 through 100 will be written on the screen, and when the number becomes 101, loop will terminate, and you can put in a conclusion after that if you like, but there's no need for it. Now, when you that C out finished is executed, at that point n is 101. You have to remember when the program finishes, the n is more than whatever the condition was. So here in this program, the condition was n less than or equal to 100. So when the program finishes, n will be 101. If you need to use that n, you need to remember n has 101 now. So if you remember that, then you can adjust the program accordingly. Okay, moving on to more examples. Our next example is the question of how to determine the smallest power of number that is a power of 3 and less than 200. In other words, 3 to the power some power will be over 200. And we want to determine what power of 300 is just over 200, but it's just over 200. That means the very next number over 200. So, I mean, in this question, we can answer manually by hand, but a similar question, if I ask you, what is the 3 to the power 1 will be over 2000, then that's going to be difficult to figure out manually. So you need a computer program when the number is very big. So here I'm using a small number so that we can understand it, but you need computer program and the numbers are large. All right, so let me clear the board here and explain what it is we are trying to do. 3 raised to what power is over 200, just over 200. So if I want to do it manually, then here is how it'll be. I start my n at start my n at 1 or 3. You can start at n at 1 or 3. And then I'm going to keep multiplying by 3. I need to generate all the powers of 3. So that only way to do that is to keep multiplying this by 3. If I multiply this by 3, then I'll get 3. And that's not over 100. So I multiply by another 3, then it'll become 9. So you have to keep checking to see whether it's over 200 or not. So keep multiplying and then check against 200. We are looking to find the number that is a power of 3 and over 200. So I'm manually figuring out the answer now. 9 is not over 200. So multiply by another 3. Then n becomes 27. That's still not over 200. So multiply by another 3, 81, and still not over 200. So as long as it's not over 200, you have to keep multiplying. N is now 243, and now it's over 200. So now you stop the loop. Your answer is 243. Okay, 243 is the number that is power of 3 and over 200. That's our number. Okay, so the question is, how do we write the program? Okay, I had to start n at 1. You can make it work with n starting at 3 also. Int n equal to 1. And then I'm going to multiply by 3, n equal to, so to multiply n by 3 means take n, multiply by 3, put it back in n. That's the way to multiply the value of n by 3. So after doing that, I need to check to see if it is over 200. And if it is not, I have to multiply again. So that means I need to repeat this statement. I need to repeat this, multiply n by 3 again and again, while what is true. So I need to put while here, and while what is true, should I repeat?
While n is less than 200.
Right, while n is less than 200, exactly. The wrong answer I get sometimes is while n is over 200. Well, when n is over 200, you want to stop. While n is under 100, you want to keep doing it. So you have to think of in terms of what should be true for this to go on. And n should be under 200 for this loop to go on. When n is over 200, we want to stop. So n starts at 1. So let's see how it works. We have written the loop. So n is initially 1, and n less than 200 is true. So it'll multiply by 3 and becomes 3. And then it'll go back and check the condition. It's true. So it'll multiply another 3. Now it's 9. And it'll go back. It's true. So it'll multiply again. It's now 81. Go back again. It's still true. Multiply again. 243. Go back. It's false. So when it becomes 243, the condition is false. It will terminate. So what do we do after the loop? We see out the n. N has the answer. When the loop ends, n has the answer. The number 243 is our answer. Okay, so see out n, and that'll do it. Okay, so here I needed only n equal to n times 3 inside the loop. I needed C out n only after the loop, because when the loop ends, n has the answer. I printed that. Now, if I include both in the loop, I can include both just by putting bracket around both. Now what happens? What's the difference? Anybody?
Professor, what was the question? I'm sorry.
The question is, if I include the C out n in the loop, if I put curly bracket around both of these statements, then my C out statement is inside the loop. So
that would print all the ends.
all the numbers, yes, they'll print all these numbers. That's what it's going to do. We don't want that. We only want the number that's our answer, which is 243. So that's why the C out statement should be outside. The reason I'm explaining that is because sometimes students write the wrong thing. They put both of them inside the loop, and that will that'll be wrong. That will print all the numbers. See, when you need an answer, only the answer should come out, and all these other things should not be printed. A user who is using your program should get an answer, not a whole bunch of other numbers that he doesn't need to see. Okay, so that's what you need to make sure. Only the answer is printed, and no other confusing things should be on the screen. So that's why the C out should be outside the loop, because only when the loop ends, we have the answer in N, and we are printing that. That's how your program should work. Okay, so let's let's move on. So the program for that is right here. While num is less than or equal to 200, num equal to num times 3. I just explained on the board. So we can now move on. Yeah, that's the part I already explained. If you see out inside, then you're printing all those numbers. All right, let me see if you can write this exercise. Start with the 1. If you have that ready, go ahead and type it in your chat or show it to me on the camera. Just the 1, exercise 1. If anybody has it, just show it to me or put it in the chat. I have written the structure on the screen. If anybody can tell me what to fill in with that. Okay, I see chats, so let me check.
Professor, in the while statement,
Yeah,
is it n is less than or equal to 53?
right. And less than or equal to 53 is right. Okay. And after C out N, what should I do? Alexandra has a version that's not quite right. You don't need an expression like that. It's the pattern is very clear. Look at the pattern. So Alexander, your version is not quite right. The way you're changing N is not right. So N starts at 1. I do need to print the 1. So that's why I'm saying while n is less than or equal to 53, see out n, then I had to change the n. I do need to see out first because the 1 needs to be printed. And after that, I need to change the n. Change the n how? Anybody?
You add 4.
Add 4, right. So simply add 4 because they're all going up by 4. So n equal to n plus 4. See that? That works, right? And so I started at 1 and keep going by 4 and print each one. And that's all we need. All right, so I'm going to stop here and I want you to try this second exercise. We're going to begin with the second exercise in the next class. If you try it ahead of time, you will learn better. You will learn a lot better if you try. If you just watch me do it, you won't learn much. So please try this exercise before next class. And if you have an answer, bring it up and we'll start with that discussion. All right, enjoy the rest of the day. I will see you Wednesday. The homework link is already up. I may have to add a problem to that. I'll do that right after this class. All right.
Bye, Professor.
Bye-bye. Have a nice
Thank you, Professor. Have a good one.
You too.